Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 7 of lesson number 11, Work and Energy. So in the last part, that is part 6, we saw how we can actually derive the equation for kinetic energy, right? So now you know what exactly kinetic energy is. You know how you can derive the equation for kinetic energy on the basis of the formula for work done, that is equal to force into displacement. And we know that force is equal to ma, right? And when it comes to displacement s, we have one formula as v square minus u square is equal to 2as. So what we did s is equal to v square minus u square upon 2a, right? Then we considered the initial velocity, that is u, to be 0, and the acceleration part got cancelled. So we got the formula for kinetic energy as half mv square, right? So now, like I explained you the way for like how you derive the equation for kinetic energy, you should be even able to explain it in your own word. That kind of revision I want from your end. Okay, so make sure that you keep doing that. Like you keep revising all the parts that we have studied so far. We have discussed about work in detail. We even discussed about energy, forms of energy. Then we have completed studying about kinetic energy. It's just that we have like 4 to 5 different activities to discuss. Okay, and then we have one, two, you can say, examples as well for kinetic energy to discuss. So we'll be doing them all, and then we'll start with potential energy. Okay, so before I proceed with this part, that is part 7, I want each one of you to please revise everything, like the notes that you have taken in your book starting from part 1. You need to have a thorough revision of that. So please start that, everyone. I hope every one of you have started revising about the notes that you have taken about work, about energy and all. So now I'm going to show you what the slides one by one, and I want each one of you to please go through whatever has been given on the slide. Okay, so it's going to be a kind of revision for you as well. So this is what we started with, that not much work in spite of working hard, right? I hope every one of you are going through the slide. See, you should be able to explain each and every sentence till now. Okay? After this, we discussed on this activity 11.1. So whatever question mark that is like visible to you over here, you have to make sure that you are able to answer them all. Okay, it's very important for you to answer them all. So please go through that as well, everyone. Then after this, we discussed on the scientific conception of work, which is very important. So I want you all to please go through it quickly. I hope every one of you are going through it properly. After this, we discussed on this activity 11.2. So I want each one of you to please go through this slide as well, everyone. I hope you all are able to answer the questions which have been given, because that is what is very important. Okay. Then we discussed on this activity 11.3 as well. So I want each one of you to please go through it as well. After this, we discussed on work done by a constant force. So I want you all to please go through it as well. I hope you all are going through it. After this, work done by a constant force, we discussed on that work has only magnitude and no direction. Now this is very important. I'm repeating this in every part because you'll get this as objective definitely. So make sure you know this. Okay. So please go through the slide as well, and along with that we have few more information which has been provided. So I want you all to please go through it quickly. After this, we discussed on this example 11.1, and I want each one of you to please go through this example 11.1, as this makes us aware of how to calculate the work done by an object, right? So please go through it, everyone. After this, we discussed on like one more example where you studied the angle between the two direction, how it's always going to be 180, right? And when we can say that the force or like force is positive or negative. You knowing about this is very important, whether the force like force applied is going to be positive or negative. If the force has been applied opposite to the gravitation, it means if the force is applied in the upward direction, then we say that the force is positive. But if it is applied towards the gravitation, in that case we say that the force is negative, and we indicate that through a minus sign. Okay. So sorry. After this, we discussed on this activity 11.4, and on the top you can see when like how exactly we are going to write about the force done, whether it's going to be negative or positive, right? Then we discussed on this example 11.2. So I just want each one of you to please go through it quickly. Then we discussed about energy. So I just want each one of you to please go through it quickly. I hope every one of you are going through this slide. Even like I want you all to go through it. So whatever information you have written about energy, please cross check those information and revise it once. After discussing about energy in detail, we discussed on 11.5 activity as well, and I want each one of you to please go through it as well. After this, we discussed on the different forms of energy. So I just want each one of you to please go through it as well. And you need to know that mechanical energy includes two different types of energy. One is potential energy and the other one is kinetic energy. Okay. After this forms of energy, we discussed on James Prescott Joule. So I want each one of you to please go through it as well. After this, we discussed about kinetic energy in detail. So I want each one of you to please go through it as well. Then we discussed on the derivation of kinetic energy, and I want each one of you to please go through it quickly as well. See, this is very tricky, and like you should have this in your mind how you can derive the equation for kinetic energy, which is again very important, right? Then after this, we discussed on like when we can say that the energy is like actually the kinetic energy is there, or like whether it is other type of energy or potential energy. So if the ball is at stationary position, or the bullet is inside the gun, in those cases we say that there's a potential energy. Now you have not studied about potential energy, but potential energy is like stored energy. So if you can see, like if a ball is kept stationary, it means it has some energy stored in it, right? Then bullet inside the gun also have some of the energy stored in it. Same way, when the ball starts moving, what happens? All the moving objects have this kinetic energy in them. So potential energy changes to kinetic energy over here. Okay. Then we even discussed on this activity 11.6, and I want each one of you to please go through this activity quickly. Then after this we have 4 different activities as well. See, what you need to do is set up the apparatus as shown in figure 11.5. So it's like You need to place a wooden block of known mass in front of a trolley at a convenient fixed position. Now I know you might not be having a trolley, right? But just imagine that you are placing a wooden block of known mass. So you know the mass of that wooden block and you're placing that in front of the trolley. Okay. Then place a known mass on the pan so that the trolley starts moving. Okay. So what we need to do, we need to place a known mass of pen so that the trolley should start moving, and the trolley moves forward and hits the wooden block. What will happen? The trolley will move forward and it is going to hit the wooden block. So you have to fix a stop on the table in such a manner that the trolley stops after hitting the block. So we want to stop that trolley after hitting the block, so the block gets displaced. Okay, so now note down the displacement of the block. As soon as the trolley hits the block is going to get displaced, right? And what we need to do is we need to note down the displacement of the block, and because there is a displacement which is happening, we can say that the work has been done on the block by the trolley, as the block has gained certain energy and it has even shown some displacement, right? But the question over here is, from where does this energy come from? It means from where do the block gets that energy? From where does the block, like, from where does the energy come from? So you need to find out this, like how the energy is being transmitted or how the block is getting this energy, and repeat this activity by increasing the mass on the plan, and you need to check in which case is the displacement more and in which case the work done is more. So in this activity the moving trolley does the work because the moving trolley has some energy stored in it, right? So I want you all to think on the question. See, what you have to write over here as observation is, when a mass is placed on a pen, the trolley starts moving and hits the block and it gets displaced. This is your observation. What you will write? When a mass is placed on the pen, the trolley starts moving and hits the block. So it gets displaced. And what explanation you can give over here is, when a mass is placed on a pan, it exerts a force on the trolley. So whenever a mass is going to be placed on any object, it is going to exert a force on the other object, right? So over here the object that we have is trolley, so it's going to exert a force on the trolley and the trolley starts moving. So the kinetic energy is transferred to the block. So this is how, because the moving trolley had some energy stored in it, and as soon as it strikes the wooden block, the kinetic energy is getting transferred from the moving trolley to the block, and this kinetic energy is due to change in the potential energy of the pan. Okay, so I hope now you know, because the kinetic energy is getting transferred from the moving trolley to the wooden block, that is why the wooden block shows the displacement. Okay, so you can write that when the mass is increased in the pan, this time more potential energy will be converted into kinetic energy. So the trolley will hit the block with more force and the block gets displaced more. So if the mass of the pan is increased, there will be more potential energy getting converted to kinetic energy and there will be more displacement. And in second situation you can say more work will be done. Why? Because both force and displacement are more than in the first situation. In the second situation, what is happening? We are saying that the work done will be more. But why? Because force and displacement, they are more as compared to the first situation, right? So this activity shows that due to much energy in the moving body, it causes more work done. So more energy is going to cause more work. If the energy is less, it means the work done will be less. Okay. I hope every one of you are writing whatever I just explained, because then we will be discussing on the other activities as well. We have two more activities, I guess. We'll discuss on both. So the next activity, there's an example, not an activity. C. An object of mass 15 kg is moving with a uniform velocity of 4 meter per second. Okay. What is the kinetic energy possessed by the object? So we know that the mass of the object given is 15 kg. Velocity is 4 meter per second, right? So we already know that the kinetic energy is equal to half mv square. Mass is given, velocity is given, so we can easily calculate the kinetic energy by substituting the value. So half into mass is 15, half into 15, and velocity square means 4 square. So 4 square is 16, right? So that is how once you calculate, you do the calculation part, you will get the answer as 120 joule. Now instead of writing joule, you can even write Newton per meter. Okay. So I just want each one of you to please go through it once. After this example, we have one more example. What is the work to be done to increase the velocity of car from 30 km per hour to 60 km per hour if the mass of the car is 1500 kg? So mass of the car is 1500 kg, that becomes small m. Initial velocity of the car is 30 km, u is 30 km and v is 60 km. Okay, so what we will do is we are going to convert this kilometer to meter. So for that we are multiplying it by 1000 and dividing it by 60 into 60 seconds. Okay, and we get the values in meter per second now. So what we have done in the initial stage, we have just converted kilometer to meter per second. Okay, now similarly the final velocity of the car is also given in kilometer per hour and we need to convert that into meter per second. So we'll do the same thing. Over here it will be 60 into 1000 divided by 60 into 60 seconds, and once you do that you will get the final velocity as 50 divided by 3 meter per second. Okay, so now because we have the mass, we have initial velocity, we have final velocity, right? We can apply the equation for kinetic energy. So first we will be doing it as half mu square, then we will use the equation of kinetic energy, half into mv square. Okay, so that is how work done will be equal to change in kinetic energy, right? So we are going to subtract that, like both the values that we got, the initial kinetic energy of the car, the final kinetic energy of the car and the initial kinetic energy. You are going to subtract that and you will get the work done, which is going to be equal to 156250 joule. So this is the amount of the work done by the car. Okay, so I hope you all have understood this part. I want you all to please write this in your book, as this is also again very important, so you can just take a like note on it and keep, so that you can revise it as well. Now in the next class I'm going to start with potential energy in detail, but like while discussing potential energy again, we have like activities to discuss. So we have 11.8, 11.9, 10, 11, 12, 13. Okay, so there are like 5 different activities which we will be discussing with respect to potential energy, and if possible I'll give you the difference between kinetic energy and potential energy as well. Okay, then after discussing these activities we have the next subtopic as potential energy of an object at a height. So we will be discussing on this as well, about the potential energy of an object at a height. Then after that we'll be discussing on this example 11.5, like how can we calculate the potential energy. Then we have example 11.6, and then we have other subtopic as whether we can like whether the energies that we have around us, the different forms of energy, are they interconvertible or not. Okay, so we'll be discussing on that in detail through two to three different activities. Then we'll discuss on law of conservation of energy in detail. Okay, then after that we'll discuss on this activity 11.15. Okay, then after this 11.15 we have the next subtopic as rate of doing work. Okay, so we'll be discussing on this as well. Then again we have activity 11.16. Then we have example 11.7 to discuss, 11.8 to discuss. Then after that, like after discussing all the topics, we have the last topic as commercial unit of energy. What is the commercial unit of energy? We'll be discussing at the end. Then we have example 11.9, activity 11.17, and then finally the summary discussion for the whole lesson. Okay, so after this summary we have 21 exercise questions to discuss. So we'll be doing that, and then these are the exercise questions that I'm showing you on slide. I want each one of you to please go through it quickly. I hope every one of you are going through the questions. Sorry. So this is how we will be ending up with the lesson by discussing on this 21 questions and discussing about potential energy. So we have completed with kinetic energy in this part, and I will be starting with potential energy. So maybe we'll be needing two more parts to complete the lesson. So make sure you keep on revising each and everything. As soon as we complete the lesson, you should be even able to answer the exercise and write the answers for the exercise questions on your own rather than copying it from anywhere. That kind of revision you need to have. Okay, so I'll end up with this part over here. and I will be continuing with the rest of the part for the lesson work and energy in the next part. Thank you everyone.